There we go. Looks like I'm streaming. Hey, everybody, it's Smitty here. Smitty working on something today. I'm headed back. I'm kind of in the middle of several different projects right now. I'm going to be going back and forth between them. Right now, I'm working on the power distribution thing that I wanted to do, the one that would measure current coming from a battery charger, coming in and out of the battery itself, and then going off to my load as well. Started working on this, it was in a few parts because I got interrupted in a bunch of the streams, but hopefully I won't have those problems tonight. But I'm going to be continuing work on that because turns out I'm ready for it, and I don't have it yet, so that's kind of a bummer. But all of my radio gear is currently mounted in the car, and I just don't have a way of powering it. I've been playing around with various different charge controllers. Stand by. I should have had these prepared for the stream, and I don't. Stand by. I did posted about this on Twitter. I think I showed some pictures of a module in a box that looks like this, and it's got a power input on one side and a power output on the other side. And then it has these two pots up at the top for setting the constant current and the constant voltage. And this module is crap. When I put a low resistance, high power load on it, like a 3 ohm resistor, 100 watt 3 ohm resistor that I bought specifically for this test, or two of them in series for 6 ohms, it would be pulling far less than the limited current, and the voltage would still be dropping. And you would adjust the current knob, and it wouldn't do anything, and then all of a sudden it would just jump into a different current range, and you try and turn it back, and it wouldn't go back. So it's like the pot was bad, but even the voltage regulation in it wasn't very good. So this particular module is junk. I pulled it out and replaced it with this module. Ignore all the wires hanging off, that's my stuff. With this module off of eBay, and I can put links to these, or at least this one in the show notes. This one is interesting because it's all surface mount, that big, so it's a bunch of the power transfer devices are on the bottom, they're all surface mount, and then they heat sink through the board to the heatsink itself. There's nothing underneath that heatsink. It is sinking heat away from these surface mount components on the bottom side, which is an interesting design, but it seems to work okay. It also has a constant voltage and a constant current adjustment there. And, it's a smaller surface mount chip, which obviously makes it more advanced, right? It's not stupid, it's advanced. Anyway, so I took the guts out of that box because I couldn't fit this into the box, and have the same thing. So it's a, unregulated voltage in, and then it's a buck boost module, so it will go up or down as necessary, and it does a reasonably good job of limiting current. And I used this, and I was charging the battery off of it, and it was working pretty great. And all of a sudden, I heard like a whining, a high-pitched kind of buzzing noise coming from my power supply. The power supply that was feeding this is an Astron, what is it? It's an Astron SS30M, so it's a 30 amp switching power supply from Astron, and these are really good power supplies. And for some reason, it was oscillating. The power supply started oscillating with this as its load, and I would disconnect the battery from this, so it was drawing a lot less current, and the oscillation would go away. Plug it back in, and the oscillation would come right back again. It wasn't this that was oscillating. It was causing my Astron to oscillate, and I don't know why. So I need to go hook up an O-scope to the input to this module, which is the output of the Astron, and see what's going on. I wasn't drawing any more than 4 amps, and it's a 30 amp supply, so it was doing just fine. So I'm not really sure what was going on with that. But I've got that module, and ideally this one will work out. If it doesn't, I have a third module. This one's much bigger. Lock it off. This one's much bigger. It has a much more control circuitry around it, and it's got a little fan for the heatsink to keep it cool. It is good for more power. So this one claimed it was good for 10 amps, and I'm sure that it's probably good for like 4 or 5 maybe, assuming it worked, which it doesn't. This one claims it's good for 10 amps, but 10 amps max. And I'm not sure I would trust it. I'm only planning on drawing about 4 amps through these. The current limit on these is supposed to be 4 amps because that's the charge current for my 20 amp hour Bio-NO power pack battery pack. So, a 10 amp module running at 4 amps should be pretty well over-spec'd. That's the way I like it. This one claims to be, I think it was 180 watts. And so, they're a little bit more honest because it depends on what voltage you're running through it as well as the current. But, and it also has like this nice big heavy shunt resistor right here that it uses for measuring current. But it's got this really slick OLED display, actually. It's a color LCD or color OLED, I'm not sure which, but a really nice color display, and you can adjust the constant voltage and the constant current levels electronically through this display, which is really kind of neat. It's much bigger. It's much less convenient from trying to package it up into a box. That's a much smaller board than that one is. But I think it'll do a much better job, and it's just kind of much better constructed. It was also a fair bit more expensive, but that's okay. These connectors are the really good kind of you put wires in there, and then it like moves the thing up and down instead of just bending a tab. And then once you have the wire in here, you can connect them, slide them onto the connectors on the board. And remove them again from here with so you can get them on and off the board without having to pull them out of their little sockets and everything. In general, this is a preferred board if I can find a way to mount it. But right now, I haven't tested it on the power supply yet with the load and everything. I need to do that. I'm kind of assuming it'll do well. But right now, this is the one that I have tested. And again, the idea is to plug this into a cigarette lighter adapter or some sort of a low-ish current source in a car and use it as a battery charger for my Bioenno lithium iron phosphate 20 amp hour battery, and then run the rest of my radio gear off of the battery, and then just use these to keep the battery topped off. And as long as my average power draw from the radios is less than the average power draw or the constant power availability of this module, then I'll be in good shape. But what I want is to be able to measure the current coming out of the charge controller, the current going into and out of the battery, and then current going over to my load. I want to be able to measure those three separately. And that is what this module is doing. So actually, let's bring up the schematic first. So if we remember correctly, one of these buttons, come on, there we go. If we remember correctly, this is the diagram that I was trying to draw. So input through the constant voltage, constant current source. That's what all these modules were that I was showing you. And then this box is the board that I'm making. I want to have a current meter coming into a common node in the middle, current meter going off to the battery, and a current meter going off to the load, and then measure the voltage at this point. Ideally, the voltage would actually be measured across the terminals of the battery, but I'll call this one good enough. So that's what I'm trying to build. Schematic-wise, we're going to use PCB mount Anderson power poles. That's what these are over here. So input, battery, and load, they all have a common ground, which is fine, but the input goes into the input side of a current sensor, a current meter. This current meter is good for up to 30 amps. Then the output of that goes to the common node that's tied to the input of the other two. Then the output of this one goes to the battery, and the output of this one goes to the load. So I'm just metering current. That's all I'm doing here. All of this stuff over here are just buffers. So the output of these meters is an analog voltage, and I'm just taking that analog voltage, feeding it into an op amp as a buffer, and so that it can go longer distances, and it's not as sensitive to resistance in the wire and various other things. But that buffer will then just send it off to a connector to go to a microcontroller. We got 3 of those, 1 for each of the current sensors. And then this is the voltage sense. What I'm trying to do here is measure 1/10 of this voltage here. So nominally it'll be about 14.4. Call it round up to 15 is kind of my upper limit. If I take 1/10 of that, that's 1.5 volts. And so I do that by having a little voltage divider, 80 kilo ohms to 10 kilo ohms to 10 kilo ohms. And so 80 plus 10 is 100, and I'm taking 10K out of 100, so that's 1/10. But I don't want to measure it relative to ground because I don't know that the power coming from the connector from the micro, VCC and ground is what's feeding this op amp, because that power needs to be relative to the microcontroller. It may be just a little bit higher or just a little bit lower than this ground because of ground impedance paths and whatnot. And these op amps, if ideally rail-to-rail op amps would be able to amplify a signal that's ground referenced. But if it's a little bit less than ground, or if it's a little bit less than rail-to-rail, this op amp won't be able to do it. So by stacking a 10 and a 10 and then an 80, this gives me 10% of my total voltage as a buffer. So it's going to bring it up from 0-ish to let's say 1.4, and then from 1.4 to 2.8, and then this will drop the rest of the voltage. So I'm measuring 10%, but it is up by 10%. And then this op amp is set up as a differential amplifier. So what it will actually do is measure the difference between these two voltages and add that to your ground reference here. And so this ground is the ground that we're getting from the power connector. So this will take the 0 to 1.4, 1.4 to 2.8. So the difference between those is 1.4, ground reference to that, so it'll output a 1.4 voltage. Even if this is, say, -5, so this 1.4 becomes 0.9, this 2.8 becomes a 2.3, so I got a 0.9 to a 2.3. The difference is still 1.4 volts, but it is no longer, it would be less than ground if I tied it over to there. Anyway, my hope is that this will actually give me a good 1/10 voltage reference of what this volt is here. And it's also a high impedance path between anything that I'm measuring over here, 100K to another 100K, so it is never going to, load current is never going to choose this as its path to return to the power supply. I want this ground reference to be much higher impedance than going through the power lines. And that will help that will help prevent ground loops and that kind of thing. So that's the circuit, and then a bunch of decoupling caps, because decoupling caps, one for each of the current filters, and then I think I did one decoupling cap for the op amp, and then also just a random bulk capacitor. So that's the schematic. And then this is the circuit that we're going to do. So I've got the current traces here, and I'm realizing, actually I thought about this after I stopped the stream last time around. I've got a fatter trace between the input and the battery current sensor than I do between the battery and the load, ignoring the fact that the input to battery is only going to be about 4 amps, but battery to load could be as much as 30 amps. So if anything, I'm going to want to swap the load current sensor and the input current sensor on the layout so that the shorter, or just turn this chip around. I can't do that. Bummer. That is inherent based on how we are measuring ins and outs and whatnots. I don't think I can do it. No, I can't. Because I could move this over here and put the chip in right there, and that would work. I could move this one there, but it would still have to go up there. I cannot move that one to the outside because I would have to turn it around to make it fit on the outside, and that won't work. So, yeah, we're stuck. Okay. I think I'm all right with that. What I think I am going to do, though, is take this line and drag it up. Give me some more copper. You can't catch me, copper. Okay. Excuse me. Oh, all right. Let me not do that until I get the op amp down. Do. Is that how I want to do that? You know what? I just had an idea. Hold on. Oh, dang it. No, never mind. That is... What am I doing? What? There we go. Okay. Now, I was thinking of maybe taking this chip and kind of rotating it that way, or... Sorry. I'm looking at the screen. Rotating it that way so that it was off to the side, but these pins get in the way of that. Yeah. Yeah, they would. All right, so I would have to chop into this. Yeah, so that's not going to work out. Okay, never mind. Yeah, these traces are going to be awfully darn short now because I like being on grids. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Wait, hang on. From center. 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then that's going to be 7 out there. So that's 9 in the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I got 2 additional on this one. But that's going to be 7 and 7 is 14 plus 9 is 23, which is not on a grid. Lovely. Okay, well, let's fix that. And that will actually fix both of them. Will that do it? 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so those are equally spaced now. That's good. I suppose I can just be using it down here. So X is what? Track via grid. Go back to inches. Thank you. Okay. 5.55. 6.175. I don't forget it. That seems good to me. Okay, so I'm going to bring up the schematic on my second screen so that I can see it as a reference. Okay. So let's see here. I need to throw some capacitors in here. Whoop, no. Where are my caps? C2, C3. Okay. We've also got the 6, 7, and 8. 6, 7, and 8. Okay. So 1, 2, and 3 are the filter caps for the current sensors. 6, 7, and 8 are the decoupling caps for the sensors. Those will probably all go on the bottom. Maybe. And then it'll be 3 traces coming down from each current sensor. 1 power, ground, and then the output. All right, so let's find a convenient way to place all of these. Yeah, that's not going to fit. Okay. Flip. Okay. And then I got to get VCC and ground and output, which is 7. Okay, that's easy enough. All right, so let me do similar routing for each of these. Flip, rotate. We'll put you there. Move, flip, rotate, rotate, rotate. Okay. Go back to the top layer. Okay. Do. Flip, rotate. Oh, you are like that. Okay. Move, flip, rotate, and like that. Okay. And then where am I? I'm on bottom. Go back to top. Okay. So those are the capacitors that need to be close to the device itself. Now all the current is passing on the top. But even so, you know what? I think I'm actually going to put this, I'm going to put these outlines on the bottom layer as well. And then I will via the snot out of it. Bottom, net 1, pad, P1, pad 1. Yep, bottom, okay. Doink. Oh, okay, I will drag that. What did I set my grid to? I think I set it to 5 on that. Okay. Now, what's the best way to drop vias on this? Kind of cheating, but I'm going to do it. Okay. Cat's busting through the door like the Kool-Aid man. Meow. Yeah, I know. I hear ya. Well, don't stand so close to my feet if you don't want to get stepped on. Silly cat. All right. Let's do another bottom layer here. What is that net called? R3 pad 1. Bottom R3 pad 1. Oh, there we go. And again, I'll have to drag those after setting the grid. Oh, shoot. Oh, okay. Well, I'll drag that one too then. Okay. What? Where? What? Why did that not draw? Was there an error message I didn't see? Bottom, net 3, pad 1. Is that what it is? Blast. Damn it. No, I think I can move it. All right. Oh, jeez. Nope. I can't. Start over. There might be a better way to drag a corner on that, but I don't know what it is. There we go. Oh, no. Boink. Okay, so now I got top and bottom copper. And let's do that again on all of these. No. P2 pad 1. There we go. And I will have to drag these later. That's fine. P3 pad 1. Okay. So what I'm doing is every once in a while I will need to get more precise than 25 mils, but I'd like to do most of my stuff on a 25 mil grid. So I usually keep the grid set to 25 mils, but occasionally I'll need to do something more precise than that. So I zoom in, set the higher precision on the grid there, and then we all coo. Okay. So that'll give me buckets of current carrying capacity on that. I can't do that on the ground. Poop. Because I need to get signals from there to there. And there's no way to do that. Shoot. All right, well, let's do this. Whoop, 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 whoop. Nope. Okay. Do-do-do-do. 4 diagonal. 2, 3. Okay. I'll increase the current carrying capacity of that and do it all again. Okay. We have all the vias, all the current carrying on the positive side, but on the negative side, I still don't have it, do I? Those are set to thermals. I don't want those as thermals. Front copper. Pad connection, solid. Why? What? Oh. How about on back copper? Solid. Yoink. Back copper. Solid. Okay. Edit. Back copper. Set that to solid. Okay. And redraw. Boink. Okay. That's going to be a bear to solder, but it'll be much better for a current carrying capacity. Cat going through the door again. Oh, hey, Bill. How you doing? Bill Allen says, hi, Smitty. Thank you for joining me tonight. I'm going to need that bottom to have a higher current carrying capacity. So I think I want on the bottom mask to draw some lines. And let me edit that line. Graphic line. Can I set a thickness? I can. Ha 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 ha. 2. Okay. So what I'm doing is I am. No, it's not going to do it. Okay. I am laying out some area of the board that will not have solder mask on it, which will allow me to what? Okay. Which will allow me to like add some solder to it or drop a piece of wire on or in some other way make it capable of carrying more current. And I'm going to drop several of these lines. You've probably seen this on like power supply boards. If you've ever, you don't take your power supplies apart when you're not using them? Like in computer power supplies, I've seen big traces like this have these lines on them. And by drawing this line on the solder mask, that will prevent the solder mask from arriving on there. And that'll be more obvious when we get to the Osh Park part of this. But I'm hoping that'll be enough to increase the current carrying capacity of this, because otherwise I have no way of getting the 3 wires from this section out. In theory, I could squeeze them through there, but I'd really rather not. Okay. So I'm getting happier with that. But I don't want to do that with the... I'm okay doing that with ground. I'm not okay with doing that with power. Okay. So... give me the whole damn chip. R8, R9, and R10. What? Just put them somewhere where I can get to them more easily. Yep, okay. So what did I say? 8, 9, and 10. Okay. So... I think I want to do it that way. So 8 will come... That goes to... Jesus, cat! Well... I'd say that'll learn him, but it won't. It's unlikely to. Sorry. Startled me rather a lot. Okay. What do you mean footprint R8 is found but locked? That was weird. Okay. So I actually want to swap around these op amps so that they make more sense. So it goes A, B, C, D. A is going to be measuring voltage. B is going to be measuring current on that one. C is going to measure the load current, and D will measure the battery current. So, I think I just want to swap these two. And then recreate a new net list. Generate. Save. I'm not actually changing any. Oh, well, no, I want that back. Just put it on the other screen. And then I need to read the net list. Yep, okay. And all that did is change the order of things. So R10 is going to be down there, and R9 is going to be there. Well, that's convenient. Those are nicely spaced. See, 4 and 5 are power. See, we have a whole house fan on, which is causing, apparently inviting all of the bugs. So C4 can go, no, I'm going to make it here as well. Fine. There we go. Okay. I got a lot of traces that need to go to ground, and not many that go to VCC. Although, why is it? Pin 5, where does pin 5 go? Pin 5 goes to, oh. Okay, I see why. Okay. I am probably going to lay down a power ground as well. Maybe, I don't know, we'll see. Okay. And then that voltage divider is going to be the fun part. So R1, R2, and R3. R1, R2, and R3. Oh, actually, oh, whoops, have those backwards. I would want that one. I don't think I want those there with the connectors around it. I think I want those down here. So I will go ahead and nope. Oh, shoot. That's right, because it has to go through 2 more resistors first. R4 and R5. That's why it's not giving me a rat's nest to that chip. Okay. 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 So that's my voltage divider network. R6 is still up there somewhere. R6 goes to ground. And R7. R7 is the feedback between 1 and 2. That definitely seems like a optimal layout, doesn't it? From a rat's nest perspective, anyway. So these two that go to ground, I could flop them. If I put a ground reference on the bottom, no, I don't want to put a ground on the bottom. Maybe I do. Shoot, I don't know. Do I want a ground on the bottom? Maybe I do. All right, so if I take that one and flip it over, and put it underneath that one. And take that one and flip it over and put it next to that one. Then take that one. R9. No, dang it. Flip you. flip you. Because those are all going to voltage. What voltage? What? Oh. Those go to the connector. Okay. All right. So let's lay... Yeah, I know. None of those others are ground. I'm not going to lay a ground plane all the way up into there. So I'm just going to do my ground plane here. Bottom copper, ground. Okay. Yoink. Oh. Hmm. I'm going to put that there. Drag. Man, what a drag. See what I did there? Never mind. Grounds are solid. Nope. Nope, nope, nope. Edit that. This one I want thermal. There we go. Okay, much better. And then VCC. VCC only connects to that, and then it connects up to those three. So first thing I'm going to do is I am going to rearrange these signals, because the location of those 4 signals is somewhat arbitrary. I'm not interfacing with anything else. Oh, hey, Kenneth. Oh, hi, Kenneth. I'm not interfacing with anything else yet that's been documented, so I can swap those around arbitrarily to make them more convenient. So I'm going to do in the order, I want that one to come down the middle-ish. So I want it to be BADC. Okay. So B is input. I want that one. Okay, so battery and voltage gets battery. I want voltage in the number 2 position, and then I want battery in the number 3 position, which means load goes in the number 4 position. So in case you're wondering what the heck I'm talking about, I just moved these around so that they would be easier to route, because you can do that. I can do that. I don't know if you can do it, but I can. Yep. Okay. See how much easier that is now? All right. Boink, boink, boink. And the load output, go right there. And battery goes, give it a clear berth of the power via. Oh, dun, dun, dun. Okay. Now, I've got some vias to drop. Similarly here. Debating whether I want one of these is going to have to go on the top, one on the bottom. Do I want VCC on the bottom? No, I think I want this one on the bottom because it'll chop up the ground plane less. And if I run VCC on top, it'll be okay. Okay. So, whoop. You know what? Hold on. Default add power. Track width. What did I say? 0.02 is usual for me anyway. Power. Ground. And VCC. Okay. Thank you. Which means I'm going to have to redo these because it doesn't go back and update existing. Okay. What do you mean error? Track near pad? What pad? Those are on the bottom. Pad 2 on front copper of R4. Shoot, that's right, it is. Oh, nope, okay. That answers my question. Okay. So I'm going to have to do that one differently. You don't want VCC on the bottom. It'll short to ground. VCC is usually at a higher potential than ground. Thank you for that advice, Kenneth. Smart ass. All right, well. Bad news for you. I'm doing it anyway. Well, I'm doing something anyway. Via there. Okay. Yeah, via. Okay. So the grounds are tied. Oh, an even better reason to put this on the bottom. That way it will have to go through the capacitors before it gets to the chip. Because I am going to go this way. There we go. We'll do that. Now that'll free up options. So R4 pad 2. Which one is R4? Is it top? Yeah, R4 is on top. Okay. And if I remember correctly, yeah, because the bottom side is R8, which is tied to the same node. R4 pad 2. Yeah, same thing. Okay. Bum. And then why? Ah, damn it. Okay. Why are you still rat nesting to that? R4 pad 2. R4 pad 2. They are all R4 pad 2. I don't know why you still claim to have a rat's nest to that. Okay. Okay. And then this one is a sample to that. This one. Is a sample to that. Yep. Okay. And then I got to get VCC and ground over there somehow too. What? Why did that not work? Oh, shoot. Why am I having such a hard time with this tonight? My layout foo seems to be completely failing me. For starters, I don't like this chip being off on its own like that, taking up so much board space, because that's going to extend the edge of the board out over so long. Damn it. Fucking flies. Nope, can't do that, can I? Can I do it on that side? I can. And then VCC as well. Wait, that one doesn't need to go under. That one can stay on the top side the entire time. Will you let me get that close? You will. Okay. And then my ground. What? Okay. This is not one of my prettier layouts. I have to confess, I'm not super excited and happy about how this layout is turning out. I mean, I've got these circuits hanging off to the side that are kind of just, like, this one's all twisted up. This one worked out okay. side. Okay. So I guess I get to choose-ish which side they're on. No, because the 7. The signal level, the signal pin is kind of, unless I want to bring it on that side. Yeah, VCC's kind of got to inherently be on the inside. Well, I could bring it around. I'm just trying to avoid going on the inside of that because it's getting too close to this stuff over here. It is getting awfully close to that. And for that to really truly be useful, I guess I kind of want ground to be inside of it. Wait a minute. Yeah. All right. Getting happier with that. Sorry, my shoelace came untied. At least it's symmetrically ugly. Ugh. All right, let's get this last one done. So I need to do this on the top layer. So I'll take that ground, just run it straight down and via to the ground plane. Do I want VCC? Which way do I want VCC to go? Oh. I could run that right straight down the middle. Fuck you. I didn't need the whole thing deleted. You jackass. Oh, are you going to do that? Nope, you're not going to let me do that. All right, well, I'll go back to this plan then. And then that just leaves my little signal. Actually, I'm going to do the same thing I did. Nope. Yep, jackass. Okay. And then, yep. Oh, I need to ground that as well. So, boink. There we go. And then from here, oh, no. like I said, it is not my prettiest layout by any stretch. Oh, whoops. Okay. Same thing there. That's not ground. Damn. Okay. So what do you guys think? I got 4 people watching. Kenneth was here a little earlier. I don't know if he's still around, or if he's gone off to do something else. But what are your thoughts on this? I don't believe you with that unconnected crap. Sorry, what was the result? U4 to R4. Which one is R4? That's front copper. Okay. So how is that not... That simple? That's all you needed? All right. You're not paying much attention, playing with TFTP. You're trying to get Jeremy, you're trying to show up Jeremy and say, well, look, I got all my pies booting off of TFTP. Is that what you're doing? You know what? Why do you think those grounds are not connected now? Which one do you think is not connected? Because I'm pretty sure... I don't get it. What did I just do? Oh, shit. Kenneth clarifies he's helping Jeremy. Helping Jeremy. That way I don't need to buy 8 more of them. He's talking about the Raspberry Pis that Jeremy KF7IJZ. I don't know how to pronounce his last name because I'm a horrible person. He's been trying to get his Einstein at Home Raspberry Pi cluster up and running, but it keeps having SD card failures. And Kenneth and I have been dogging him to figure out how to do NetBoot with the Raspberry Pis. So you only need one device that has a reliable disk, and all of the other ones just boot off of the network and get everything they need over their network. And for what he's doing, it's kind of the perfect way of doing it. And he's like, I'm so glad I finally convinced him to do it so that I can prove it can be done without having to buy the hardware or doing any of the work himself. So it's not so much proving it is as making somebody else do the work for you, which, good times. Okay. Now Kenneth's favorite part. Actually, no. Wait a moment. Bottom select. Wait just a second. No. Okay, you two, just get those off of there. Did I not? Ah. Really? Did I do this? I'll bet you I did all of this before I made my own components. Yes. All right. Actually, generate. Yeah, sorry. Kenneth is yelling, "Yay, hacking the silk layers!" Yeah, and so apparently I did this schematic before I made my own custom components, and so now I need to erase all those components and put them in the right place again. Footprint C1, netlist, read current netlist. You know what? I wonder if there's a way, I've never actually looked, to get it to do this for me. Footprint selection. Reference. Recognized by their reference, normal setting, or their timestamp special setting after a full schematic reannotation. No, I'm not doing that. Exchange foot. Oh, hey. All right. Let's see what that does. Did that do it? Ha! I think it did. All right, so I don't have to hack any of the resistors or capacitors anymore. But I do still need to hack these things, the silk layers of several of these bits. Okay. Let's make some of this go away. I'll keep the edge cuts there. That's front. That's back. We'll do one at a time. I'll do front first. I'm actually going to need the pads. Make references go away because I'm not actually using them. Will you let me change? Huh. Who knew I could do that? Yeah. Kenneth expresses surprise at that actually worked. Dropping in those sensors, or dropping in those new components. I kind of am too, to be perfectly frank. Let's do front silk. What did I do? Input. 7, and do that. Input. Input translation. Input translation. Input translation. Get the reference, anyone? 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 No? Orbital? 90s? There is the theory of the Mobius, a twist in the fabric of space where time becomes a loop. Time becomes a loop. Time becomes a loop. Boom, 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 boom. Yeah, I'm not a very good beatboxer. Never mind. Input battery load. Okay. That's looking pretty good. Go to bottom silk. Pads back. Front. Okay. Where are the values? Text back, text front. There we go. Okay. So hey, David McKay. He says, "Hey, Sparky, what you up to?" I think I'm Sparky in that sentence. And yeah, all right, just watching Smitty playing with TFTP. Well, watching Smitty and playing with TFTP, those are two separate things, but fair enough. Yes. I am trying to lay out my battery interface current meter thingy. I kind of don't want references because they're not going to get printed. Okay. I should probably label these, shouldn't I? Okay. Text. BCC. And we're going to make these smaller for 4. And I'm going to make these left justified. Okay. Too large. Okay, fine. Whoops, wrong side. Put that on the front silk. And 0.1's fine. Okay. Mirrored normal. Thank you. Okay. And we're going to rotate that like that. And then I'm going to copy it. Edit. This one I know is ground. All right. So edit input. Edit voltage 1/10 voltage. Edit battery current. Edit load current. Okay. Dave says he thinks I was done with this one. No, I didn't finish it last time. I got to a certain point, my shoe is untied and it's driving me up the wall. No, I didn't finish it last time. I got to a certain point and just kind of gave up for the night. Sorry, having an untied shoe feels weird. Yeah, no, so I'm finishing it up tonight. Okay. I need to put some more copyrights on here. Copy, rotate, rotate, rotate. Oh, you know what? Actually, that's a good reason to move that up to there. And there. Dave McKay asks what city I live in. Yeah, I live in the San Luis Obispo area. Not the city proper, but the general area. Oh, Dave is saying that if I do live in San Luis Obispo or somewhere near there, which I do, that you might have to come ring my doorbell when he comes to visit his mom in Santa Maria, which is a town nearby. I request that you announce your presence first. But yeah, if you find yourself up this way, let me know and we'll go grab a tasty meal of some kind or something along those lines. I'd love to meet up. Okay, sorry, I'm a little distracted because I'm thinking about this. I want to go see what Osh Park has to say. Because it's what I do. Where are you? What city are you in, Dave? David, excuse me. Not speaker mixer, mobile power, KiCad. Let's try this. Dum-de-dum-dum-dum. Oh, geez, it's late. It's 11:15 already. All right, so let's take a look at these files. Oh, I didn't actually label what the components up there were. Whoops. I should probably do that. I really don't like the fact that that stuff comes down between the battery and the load. I wish that came down between the input and the battery, because that would mean I could put a giant bar across the battery and the load like I can right now between the input and the battery on the negative side as well, and increase that current carrying capacity. Yeah, I think that'll do. Got my little fishies in there, because, halibut. This doesn't feel right. What am I doing wrong up here? Oh, at the very least, I can put my text up there, although I probably shouldn't. What am I doing wrong up there? Is that the right way to do this? Just have a crap ton of copper like that? Should I be putting these bars up there as well? Because I've got the top and bottom layer. Whoa, I lost my VCC. Okay, I bet you that happened when I moved it instead of copying it. All right. Well, I think I'm going to call that a board. I will go ahead and order it separately. All right, so this evening's revelries felt a little weird to me, but hopefully you guys still enjoyed it, learned something out of it. I appreciate it. It's time for me to go crawl into bed, so I will order this some other time. But thank you very much, everybody, for joining me. Again, I'm Smitty Halibut, SmittyHalibut. On Twitter is probably the best place to catch hold of me, or in the comments below down here. And yeah, I'll be back working on probably the satellite optimized radio. Let's do this. I'll probably be back on some other night this week working on the satellite optimized radio that I started working on. Go check out the playlist for that, because I think that's going to be a really cool project. I wanted to get this one here, this power board, up and running, because I need it. I actually want to have it, not just a random idea, but this is going to help me put things mounted in my car. Mount holes. Shit. Okay. Yeah, I've got more work to do on this, so I'm definitely not ordering it tonight. But anyway, yeah. So catch me on Twitter. Tell me hi. Say hi. Tell me what you guys are working on. I always love hearing what projects you guys are in the middle of. Guys and gals, folks. Sorry, I need to be better about that. And yeah, I'll catch you next time. Thank you very much for watching, and be good humans. We'll catch you next time. And the obligatory countdown until I think that the stream is done. I'm going to look for the thumbs up in the live stream, and then I'm going to click stop streaming, because there's a delay, and sometimes when I click stop streaming, YouTube actually just cuts the stream off right there. There's the thumbs up.